Hello. In this exercise, we describe how different objects, primarily let's say a styrofoam ball, an electron, and a proton, behave as far as kinematics go in the presence of an electric field. So let's start with part A. It consists of three different configurations. Once we have a ball, and then next we have an electron and then a proton. So let's start with the ball, and it's not written explicitly here, so I should point out neglect gravity. It's actually not very crucial when it comes to electron and a proton, but for the ball scenario it is good to specifically say neglect gravity, or else you have to take care of that. So it just simplifies if you neglect that. So the forces acting in that case is just the electric force. So we have mass times acceleration. So mass of the ball in this case, acceleration of the ball, that's equal to the force acting on the ball. For ball is electrically charged, so it is Q times the electric field. So the basic new concept here is that the force is charge times the electric field. So let me write that down. So force is charge times the electric field. That's the basic uh, definition. So mass times acceleration is equal to force. Force is charge times electric field in the case of an electric field. And so acceleration can be calculated then. So A for the ball is Q times E over M, which is 1.0 into 10 raised to minus 6. Electric field is 1000. So let me write that as 10 raised to 3. Anyway, there are two sig digits decided by the smallest one, so it's 10 raised to 3 divided by mass, which is 10 grams, that's 0.010 kgs. And that's equal to, there's a 10 raised to minus 6, 10 raised to minus 2 in the denominator, that's 10 raised to minus 4. So there's 0.10 meters per second square. Compare this with gravity. Gravity is about 9.8 meters per second square, or about 10 meters per second square, and this is significantly less, 1,000 times smaller, or 100 times smaller than that. So that's the acceleration a ball will experience, still in the order, at least within 2 orders of acceleration due to gravity. Electron does a pretty similar thing. So next is an electron. We have mass times acceleration is equal to, again, Q times E. And the acceleration due to the electron is, explicitly right, electron is equal to the charge of the electron now. Electric field remains the same, and this time it's the mass of the electron. Charge on the electron is 1.6 into 10 raised to minus 19 coulombs. Electric field remains the same, that's 1000, so it's 10 raised to 3 divided by its mass, which is 9.1 into 10 raised to minus 31 kg, really tiny number. so, so that's equal to 1.6 divided by 9.1, that's 0.1718. And we have 10 raised to minus 16 on the numerator. So that gives 10 raised to 15 as a factor. Writing it in scientific notation, we have 1.8 into 10 raised to 14 meters per second squared. And here it is very clearly seen that the acceleration due to gravity, which will be of the order of 10 raised to 1, 9.8 meters per second square, is completely negligible when in front of a humongous number like 10 raised to 14. So there's no need to keep, unless you're keeping 14 significant digits, there is no need to talk about gravity, even if gravity was, was there. Proton is very similar, except the mass is different. So charge times electric field, mass times acceleration of the proton. So acceleration of the proton now is QE over m. Everything remains, most of things remain the same. 1.6 into 10 raised to minus 19. Charge is the same on both electron and proton, but its mass is now significantly heavier. It's 1.67 into 10 raised to minus 27. Less number of negative um, orders means that it is actually heavier. Proton is heavier than electron, and that gives us 1.6 divided by 1.67, and that's 9.6 into this time. It is 10 raised to minus 16 and 10 raised to 27. So it's about 10 raised to 11. And one of the powers going right in the 0.96 as 9.6. So that's 9.6 into 10 raised to 10 meters per second square. So the acceleration is smaller for a proton, it being heavier, but nevertheless, it is significantly high, 10 raised to 10 orders of magnitude higher than acceleration due to gravity. So again, gravity can be reflected in you. Notice one point that in gravitational field, the accelerations are independent of the masses. Here, it is different masses behave differently because when it is gravity, the masses cancel out. Here, there is no mass on the right-hand side, so it doesn't cancel out. So m comes in the denominator. The heavier mass accelerates less. So that's one slight difference with respect to gravity. Let's come to part B. This is kinematics. Kinematics, we have told each of small electron and a proton now is in the presence of an electric field, and they start from rest. So let's when we're doing kinematics, there are 5 variables. So it's the displacement, time taken, initial velocity, final velocity, and the acceleration. Acceleration for the ball is 0.10 meters per second square. Initial velocity is 0 for 3 of them. And in part B, we are doing time is given, so it's 1.0 nanoseconds, 10 raised to minus 9 seconds. And we are interested in finding out how far, determine the distance traveled. So this is what we are exploring. V final is a missing variable, and the equation we use is delta x is equal to V initial delta t plus half a delta t squared. V initial is 0, so when it comes to the ball, delta x, let's say by the ball, is V initial anyway is 0 for all 3, so it is equal to half. Acceleration is 0.10 meters per second square. times delta t square, which is really tiny number in this for a ball. So it's 10 raised to minus 18, and that's 0.5. So it's 0.5 into 10 raised to minus 18 seconds. That's sorry, 10 raised to minus 18 meters, right, because this is distance. That's really tiny enough amount of distance a ball can move, so it will not be observed at all. We will hardly make this observation. And that's primarily because the time we are talking about is really tiny. Talking about electron now, the electron's acceleration is 1.8 into 10 raised to 14 meters per second square. So again, if we do the distance traveled by an electron, so it's half times now acceleration is large. So, but time, even though it is small, acceleration can compensate. That's 10 raised to minus 18. That's 10 raised to 14. So that's 10 raised to minus 4. So that's about 0.9 into 10 raised to minus 4 meters. That's about 0.09 millimeters. Like 260, it's millimeters. Still small, but notice with the huge acceleration and small time periods, it can travel this much of a distance in that small time period, which is a large distance. When you compare to the size of an electron. So the scales are entirely different in this case. Proton, same idea, except now the acceleration is different. So acceleration this time is 9.6 into 10 raised to 10 meters per second square. And that's 9.6 into 10 raised to 10. And the time is the same. 9.6 is 4.8. But now this is 10 raised to minus 18. That's 10 raised to 10. So that's 10 raised to minus 8 meters. That's about 0.5 or 0.48 nanometers. That's an atomic scale yet. So here we almost reached in a micrometer. So this was equal to um, 90 micrometers, if you want, which means about there can be about 90 bacteria that you can fit in within that distance. So that's a large number, and here this is in nanometers, small number. So proton and electrons are as scales apart, orders of magnitude are entirely different. Part C, it's the same configuration, distance, time, initial velocities, all this remain the same, except now we are interested in the final velocity, starting from determine the speed obtained by the ball. So now we use the equation V final is equal to V initial plus A times delta T. Right? Initial again is 0. So for the ball, V final is equal to A times delta T. No squared quantity coming in, so this time it will be different. So it's 0.10 into 1.0 into 10 raised to minus 9. So that's 1.0 into 10 raised to minus 10 meters per second. Small speed, 10 raised to minus 10 for a object like a ball is hardly observable. Electron gains a velocity, same expression. So that's 1.8 into 10 raised to 14, A times delta T times 1.0 into 10 raised to minus 9. So that's 1.8 into 10 raised to 5 meters per second. That's a significant amount of speed that it has picked up. Remember, 10 raised to 8 is the speed of light. That's the maximum speed possible. And this is almost at the scale of the speed at which planets move around sun. Very large speed, much more than interstate speeds. Internet, of course, moves at the speed of light. So proton, repeat the same idea, except now it is 9.6 into 10 raised to 10. Now more the order of the time scale. So it's 96 meters per second. It's about 192 miles per hour, which is of the order of the speeds in a speedway. So this again tells us different uh, scales in which the speeds change, even if it is an electron and proton. Electron being very light behaves very differently in the presence of an electric field than proton. With that, let me stop sharing and let me stop the recording.